Section: Introduction. In this section, we address a key challenge in the development of large language models, LLMs, which is balancing performance and efficiency. A notable aspect of GPT-5 is its ability to route queries to different models based on their needs. As highlighted in the introduction to GPT-5, it features a general model for most questions and a more advanced reasoning model for complex problems, along with a real-time router that determines which model to use based on the type and difficulty of the conversation. The efficient model is less costly and faster but has limited capabilities, while the deeper reasoning model is more capable but comes with higher costs and delays. During the inference process, GPT-5's router assigns each query to one model, aiming to find a balance between performance and efficiency. In our work, we enhance this routing process to better optimize this trade-off. We build on our previous research, known as Avengers, which demonstrated that a straightforward routing method using 10 models, each with around 7 billion parameters, outperformed GPT 4.1 and 4.5 across 15 datasets. We introduce Avengers-Pro, which focuses on the performance-efficiency balance through 3 simple steps. First, we encode queries using a text embedding model. Second, we group these queries by their semantic similarities. And third, we assess the models within each group based on a performance efficiency score influenced by a trade-off parameter. During inference, we embed each query and identify its closest clusters. We then select the model with the best performance efficiency score from those clusters to generate a response. In our experiments, Avengers-Pro includes 8 models from 4 different families. We test it against 6 challenging benchmarks and find that it achieves a 7% performance improvement over the best single model, GPT-5 Medium, while maintaining a similar cost. Additionally, it can reduce costs by 27% while keeping performance comparable. By adjusting the trade-off parameter, we can further enhance the balance between performance and efficiency. For instance, to match 90% of GPT-5 Medium's performance, Avengers-Pro can lower costs significantly compared to both GPT-5 Medium and Gemini 2.5 Pro. We also observe that Avengers-Pro consistently provides the best performance for any given cost and the lowest cost for any fixed performance target. In terms of routing for the performance efficiency trade-off, Avengers-Pro combines various LLMs with a router that requires a clear understanding of each model's capabilities and efficiencies across different tasks. To achieve this, we use a set of labeled query answer pairs. Each query is encoded into a semantic vector, which we then cluster into groups representing similar query types. We evaluate each model's performance and efficiency within these clusters. We define a performance profile for each model based on its accuracy in each cluster and an efficiency profile based on the costs incurred. We calculate a performance efficiency score for each model in each cluster, which is influenced by the trade-off parameter. During inference, we encode incoming queries, assign them to the nearest clusters, and sum the performance efficiency scores for each model. The model with the highest total score is chosen to respond. Section Summary. In this section, we address the trade-off between performance and efficiency in large language models, LLMs, by introducing the Avengers-Pro, which utilizes a dynamic routing system to select the most suitable model for each query based on a performance efficiency score. Our experiments demonstrate that Avengers-Pro can achieve higher accuracy at a comparable cost or reduce costs significantly while maintaining performance, effectively optimizing the balance between these 2 critical factors. Section: Experiments. In this section, we compare the performance and efficiency of Avengers-Pro with leading single models. For our experiments, we evaluate 8 prominent models that differ in their capabilities and efficiency. These include Google's Gemini 2.5 Flash and Gemini 2.5 Pro, Anthropic's Claude 4.1 Opus and Claude 4, OpenAI's GPT-5 Chat and GPT-5 Medium, and Qwen's Qwen 3-235B A22B 2507 and Qwen 3-235B Thinking 2507. We access these models via the Open Router API, which allows us to conduct consistent experiments across them. The pricing details for these models are provided in Table 1, noting that prices for the Qwen 3 models may vary by provider, but we report the prices from OpenRouter. We utilize 6 challenging benchmarks that assess advanced reasoning and general knowledge, summarized in a table. These benchmarks include GPQA Diamond, a graduate-level Q&A test, Humans Last Exam, HLE, a multimodal academic question benchmark where we only use text, ARC-AGI, which tests fluid intelligence, Simple QA, focused on factual questions, Live Code Bench, a coding benchmark that updates with new problems, and Tau Squared Bench, which evaluates reasoning and user guidance. For all benchmarks, we follow the official protocols and use their recommended settings. In terms of implementation, we apply k-means clustering with 60 clusters. Each query is transformed into a 4096-dimensional semantic vector using the Qwen 3 embedding 8b. We split our data into 70% for fitting the clustering model and 30% for routing and evaluation. During inference, we compute the embedding of incoming queries and find the 4 nearest clusters. We then sum the cost capability scores for each model across these clusters and select the model with the highest total to generate responses. Our results show that Avengers-Pro outperforms all individual models. Among the 8 models, GPT-5 Medium achieves the highest average accuracy at 62.25%, followed by Gemini 2.5 Pro at 56.08% and Qwen 3 Thinking at 48.11%. With a sufficiently high trade-off parameter, Avengers-Pro reaches an average accuracy of 66.66% when alpha is set to 1.0, which is 7% higher than GPT-5 Medium and 19% higher than Gemini 2.5 Pro. Furthermore, Avengers-Pro demonstrates a better performance efficiency trade-off. At a performance level similar to GPT-5 Medium, Avengers-Pro with alpha at 0.53 incurs 27% lower costs. At 90% of GPT-5 Medium's performance, it reduces costs by 63%. When matching the performance of Gemini 2.5 Pro, it cuts costs by 81%, and at the level of CLAUDE 4.1 Opus, it achieves a 92% cost reduction with alpha at 0.25. As illustrated in Figure 1a, Avengers-Pro establishes a Pareto frontier, meaning no single model can provide both higher performance and greater efficiency than it. Essentially, Avengers-Pro offers the best performance for any cost and the lowest cost for any performance level. Section Summary. In this section, we compare the performance and efficiency of Avengers-Pro against 8 leading models across 6 challenging benchmarks, demonstrating that Avengers-Pro outperforms all individual models, achieving up to 66.66% accuracy while significantly reducing costs compared to its competitors. Our findings indicate that Avengers-Pro provides the best performance efficiency trade-off, establishing a Pareto frontier that no single model can surpass. Section. Effects of the trade-off parameter. In this section, we examine the effects of the trade-off parameter. We gradually increase this parameter, which we refer to as alpha, giving more importance to performance over efficiency. We observe that as alpha rises, the average accuracy increases quickly for lower values of alpha and then levels off around alpha equal to 0.6. Meanwhile, the cost stays low until alpha reaches about 0.4, after which it increases sharply. These observations highlight 2 key points, or elbows, at around 0.4 and 0.6, where we find beneficial trade-offs. Next, we look at the proportion of model usage. When alpha is low, we notice that Avengers-Pro tends to favor the Qwen 3 and Qwen 3 Thinking models, directing a large number of queries to these cost-effective options. As we increase alpha, the use of GPT-5 Medium rises quickly, and we also see an increase in the usage of Gemini 2.5 Pro and Claude Opus 4.1, which are better at complex reasoning but come with a higher cost.